Okay, dear students, let us do some problems on fixed bias or base bias resistor method and also on voltage divider bias method. So the first problem is like this. Here you have shown the circuit here. This is the circuit which will be given in the examination. In this circuit, RB base resistor, RC collector resistor, voltage between this base and emitter is given as 0.7 volts. The current flows through IB is given as IB equals 40 microampere. Micro means 10 power minus 6 ampere. And beta, the current gain in this common emitter mode. Emitter is common for both input and output. Beta equals 80. So what is the problem? See, for the circuit fixed bias circuit shown below, for this circuit, determine collector current, that is IC, collector resistance, that is RC, and base resistance, that is RB. Also collector emitter voltage, that is voltage between this collector and emitter. Since emitter is ground, the entire is VCE. Here this voltage is given as VC equals 6 volts. From year to year, the applied voltage which is 12 volts. Among this, VC is the voltage between this collector and ground given 6 volts. Therefore, VCE is equal to 6 volts. First one, collector current. To calculate collector current, let us consider base current is given. Base current is 40 microampere. Base current is 40 microampere. That is equal to 40 into 10 power minus 6 ampere. And the current gain beta is given in the circuit. Beta equals 80. Therefore, beta equals 80. What is the collector current? You know from definition, beta is equal to current gain in common emitter mode. Beta is equal to IC divided by IB. Therefore, IC is equal to beta into IB. Beta equals IC by IB. Therefore, IC is equal to cross multiplication beta IB, where beta is 80. IB is 40 into 10 power minus 6. That is equal to 8 that is 3.2 milliampere. You can calculate this. Okay, 3.2 milliampere. Next, B. What you have to collect? Collector resistance. What is RC? To calculate RC, you should know IC, because IC is already calculated here. It is 3.2 milliampere. See this circuit. From year to year, the voltage applied is 12 volts. Okay. That is VCC. Year to year, it is 12 volt. From year to year, it is VC, which is equal to VC equals 6 volts given. Therefore, voltage drop across this is entire voltage minus this. So, I will write voltage drop across this is, say, VRC, voltage across resistance of the collector. And this is VCE is equal to VC equals 6 volts with respect to ground. And the entire voltage applied is VCC is equal to 12 volts. So from this figure, VCC is equal to VCR2 plus VCE. Therefore, from this we get VCC is equal to VCR2 plus VCE. That is 12. VCC is 12. This is VRC. This is only 6 volts given. Therefore, VCC is equal to VCR2. VCC is 12 volts plus VC is 6 volts. Or VCR2 is equal to 12 minus 6 equals 6 volt. But we know that by definition, this voltage across RC is current into resistance. IC into RC is voltage across this. Voltage across this, that is VC is equal to IC into RC. Therefore, this is VRC. Sorry, this I will write this as VRC. VRC. I will write this as VRC. Therefore, VRC is equal to, here this is 6 volts. By definition, this is IC RC is equal to 6 volt. Therefore, RC collector resistance is equal to 6 divided by IC. 6 divided by IC have calculated as 3.2 milliampere. Therefore, divided by 3.2 milli, which is equal to 6 volts divided by 3.2 into 10 power minus 3, because milli is 10 power minus 3. When it goes up, it becomes 10 power plus 3, and the unit of resistance is kilo ohm. 6 by 3.2, how much? 6 divided by 3.2 is 1.875. Therefore, 6 by 3.2 is 1.875. 10 power minus 3, when it goes up, it becomes plus 3. Unit of resistance is ohm. Or you can write this as 1.8. What you have to collect? Base resistance. RB is how much? Okay. See, from year to year, that is VCC equals 12 volts. Therefore, from this left side, this 12 volts is equal to voltage drop across this plus voltage across this. Voltage across this is 0.7. I will write this as base emitter voltage is equal to 0.7 volts. Then from this circuit, VCC, from here to here it is VCC equals voltage drop across this is IBRB. Current into resistance is voltage across RB plus voltage between base and emitter, that is VBE. Therefore, from the left side of the circuit, we get VCC is equal to IBRB plus VBE. VCC is 12 volts. IB is given as 40 into 10 power minus 6. That is 40 microampere. 40 microampere. So, and VBE, that is RB into RB, plus VB is given as 0.7 volt. Therefore, 40 into 10 power minus 6 IB is equal to 12 minus 0.7, which is equal to 11.3 volts. Therefore, IB is equal to 11.3 volts divided by 40 into 10 power minus 6. On calculating this, you will get, use the calculator and calculate, 11.3 divided by 40 equals 0.2825 is equal to 0.2825. When 10 power minus 6 goes upward, it becomes 10 power plus 6. I can write this as 0.285 into 10 power 3 into 10 power 3, 10 power 6. So 0.285 into 10 power 3 is 285. Sorry, for IB we have substituted here. This is RB. This is base resistance RB. So when it 0.285 into 10 power 3 is 285 into 10 power 3 is kilo. Therefore, base resistance is 285 kilo ohm. And last one is collector emitter voltage. Collector emitter voltage, that is VCE. To calculate VCE, consider the right side of the circuit. Okay, from year to year, the voltage is 12 volts given. From year to year, the voltage is 6 volts given. Therefore, VC means collector voltage. That is nothing but collector emitter voltage. Since VC equals 6, VCE is also 6. Therefore, and you can also calculate like this. VCC is equal to VC plus VCE. Okay. VCC is, this is 12 equals this is 6 plus VCE, or VCE is equal to 12 minus 6 equals 6 volt. Okay. Yes. Okay, dear students. Now let us consider the second problem. In the second problem, the base resistor method circuit is given, in which the current flows through this RB is given, IB equals 20 microampere, and the collector resistance RC is given 2.2 kilo ohm, and the collector emitter voltage, that is, this is collector and this is emitter. So voltage between collector, since emitter is connected to ground, the collector emitter voltage is 7.2 volts. What is the RB value, and what is, to calculate RB you need beta, because beta equals IC by IB. IB is given, therefore you have to calculate IC first. Here the supply voltage is 16 volts is given. Okay, calculate for the circuit shown below, calculate the base resistance, that is RB, and current gain, that is beta. So beta is equal to how much? You know that to calculate beta is nothing but collector current by base current. Therefore, here IB is known, given. To calculate beta, IC should be known. Therefore, you have to calculate IC now. From year to year, the applied voltage is 12 volts VCC, which is equal to voltage drop across this, that is ICRC, plus voltage between these 2 points, that is VCE. Therefore, VCC is equal to, from this expression, from year to year, it is VCC is equal to voltage drop across this plus voltage drop across this. Voltage drop across this is ICRC plus VCE. Therefore, this is VCC equals ICRC plus VCE. And VCC, therefore ICRC is equal to VCC minus VCE. VCC is 16 minus VCE is given as 7.2 volts. Therefore, this is equal to 8.8 volts. From this you can calculate collector current. IC is equal to 8.8 volts divided by RC, because ICRC is 8.8. Therefore, IC is equal to 8.8 volts divided by RC, which is equal to 8.8 divided by RC is given 2.2 kilo ohm. RC is 2.2 kilo ohm. Therefore, this is divided by 2.2 kilo, which is equal to 8.8 divided by 2.2 into kilo means 10 power 3. Okay, when it goes up, it becomes minus 3. Therefore, IC is equal to 8.8 by 2.2 is equal to 4. 10 power minus 3 unit is ampere. Therefore, this is equal to 4 milliampere. 10 power minus 3 is milli. So, once you know the collector current IC, you can calculate beta. IB is known, IC is calculated. Therefore, beta equals IC by IB. Now, beta equals IC by IB. IC is calculated as 4 milliampere, 4 into 10 power minus 3, or IB is given as 20 microampere, 20 into 10 power minus 6, which is equal to 4 by 20 into 10 power 3 minus 3 minus 6 get cancelled, 10 power minus 3 denominator. When it goes up, it becomes plus 3. 4 by 20 is how much? 2.2 into 10 power 3, which is equal to 200. Beta has no unit because it is a gain. Current by current. This is also milliampere. This is also ampere. Get cancelled. Therefore, gain has no unit, whether current gain, voltage gain, power gain. Upper and lower denominators are same. Numerator and denominator quantities are same. units are same, therefore it has no unit. It is a ratio. Next, what you have to calculate, once you know the current gain, you have to calculate base resistance RB. How do you calculate base resistance? See, from here to here, the applied voltage is 16 volts. This 16 volts is equal to voltage drop across this plus voltage drop across this. That is VCC, 16 is VCC, is equal to voltage drop across this is IBRB plus VBE. I will call this as base emitter as VBE. It is given as 0.7 volts. Therefore, from this expression, you can write, see, once again, I will tell you, here to here it is VCC. VCC is equal to voltage across this, that is IBRB, plus voltage between these two, that is VBE. Therefore, VCC is equal to IBRB plus VBE, or IBRB is equal to VCC minus VBE. Therefore, IB into RB equals VCC is 16 minus VB is 0.7. That is equal to, I think it is 15.3 volts. Therefore, base resistance RB is equal to 15.3 divided by IB. 15.3, IB is 20 into 10 power minus 6 given 20 microampere. Therefore, 15.3 divided by 20 is 15.3 divided by 20 equals 0.765. This is 0.765. When 10 power minus 3 goes up, it is 10 power plus 3, which is plus 6. And you can write this as 765 into 10 power 3, or it is 765 kilo ohm.